Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohdsyaufikhelmiyusoff. My supervisor Dr. Sharifah binti Abdullah. My co-supervisor Dr. Muhammad Nahasri bin Muhammad Siddiq. Today I want to present on destructive testing of reservoir water tank. So this is our table contents, introduction until Gantt chart. So this our case study. Reservoir water tanks were built since 2002. Concrete cylinder RC structures. This height 38.6 meters. So this capacity of reservoir water tanks consists to 2089.84 meter cube. So this our ppm water storage tank consists for the main tower tank, reservoir tower tank, east tower tank, and suction tanks. So this is our case study view, which consists by using a drone for the reservoir water tank. So this is our as-built drawing, which consists the typical of the dimension for the reservoir water tank. So our problem statements. One, which is what the problem of damage and deterioration of concrete structure reservoir water tanks. So where we consist to entity internal and external structure of reservoir water tank. So when during the visual inspection internal and external structure. So why we do it that the reservoir had operated more than 10 years, need to be checked and verify the condition of the structures. So the second problem statement, what a negative impact of the consumer quality of the water supply and safety maintenance team for regular water tank checking to the reservoir water tank. So where the superstructure damage at internal and external reservoir water tank, and when during the inspection and collecting data visual survey, which consists the NDT rebound hammer, UPV, and concrete cover survey. So why we use the NDT? Because the high reservoir water tank must be assessed safety guidelines, best method to repair the strengthening of the structure element. This is our objective to assess the cracking type or condition the reservoir water tank. This is one. Second, to determine the properties of a structure concrete wall of reservoir water tank. Two, and three, to propose the best method of repairing and retrofit the concrete water tank. The fourth, to develop the concrete water tank security framework as engineering guidelines. And last one but not least, to validate the developed framework in structure engineering analysis. This is our contents of the objective. This scope of a study, visual inspection and evaluate the type of the crack structure using the drone. Second, assessment integrity NDT to find the structure behavior. Third, evaluate collect data from the NDT method to find the result strength and quality concrete structure. Fourth, determine the reinforcement detection and precisely measure the concrete cover over each reinforced steel bar. And the last one, propose the repairing method of concrete water tank by using the result from NDT test method. So the significance of the studies need to study and analysis involve a long-term repair is conduct cause. This problem will increase the risk of cracking in a ppm reservoir water tank, result in the water supply crisis for consumer. So the second, support ppm engineering department investigate damage of the concrete water tank. by using NDT methods. To assist the engineer to root cause of the water tank structure repairing by using result of NDT test method. The last contribute to enhance knowledge information as well as guidelines. Reference method be referring reusable RC structure for other hospitals maintenance. So our literature review consists to the concrete cracking, identifying performance of concrete structure conclusions. So this have a subtopic for the introduction benefits, testing approach, a theoretical conclusion. Then these are our literature review summary based on the latest previous studies for drone assessment, compressive strength assessment. So this is our methodology. This is we got a six stage. The first stage, which is background of the study. Second stage, literature review. Third stage, NDT methods, which is consists visual inspection, rebound hammer, UPV, and cover meter. The fourth, it is assessment for the uh, data analysis. Image for the image segmentation for the rebound hammer consists three members from the dome, beam, and column. UPV consists to the dome, beam, and column. There's a concrete cover meter testing only for the dome and wall. So all of this before we consist the data analysis, the safety condition must be prepared and safety first. Okay. The fifth stage, which is consists the result of from the data collection, and from that result, can conclude the structure audit analysis result from NDT method. So the finding are repairing of the strengthening structure concrete. So last stage will consist the conclusion, thesis writing, and okay. So our data collection consists by visual inspection, rebound hammer, UPV, cover meter, and the last repairing concrete cover. So at that data analysis, the method is analysis for field work assessment by visual survey, rebound hammer, UPV, and cover meter test. The data collecting, before we do the data collecting, must be consider the properties of the safety condition on the site, because this is a high risk for the uh, highest building consists to 38.6 meter of the reservoir tower. So this is a view. We use a skylift to mobilize to got the external structure consists to the taking the data from the NDT methods. So this planning, control, and supervising a work reservoir water tank also know the highest building. The safety must be performed the competence individual who the necessary. So we have checked the hierarchy form to the OSHI PPM. So we have do the hierarchy form before this data collecting will get at the reservoir water tank. So this is example hierarchy form. So regard to the adjective, from this area we can see mini spoiling and cracking type of the structure. So this is our visual survey. Use the drone by see the visual have a crack at the dome. So for the rebound hammer, we consist the procedure using the objective to determine the concrete strength and measure the strength of uniformity of the concrete. So this is our procedure from this study. So by using for the chart for along the line A and B, so press the plugger again to the surface of the concrete. Before we plug against to the concrete, the surface must be clear without any droplets or uneven surface. So this is will affect the data collecting from the surface condition. Okay, this is our apparatus from using the rebound hammer. Uh, uh, this is me. I'm doing the data collecting myself at the inside. This is inside the reservoir water tank. So these are calculation for the dome area. So the finding of the summary result for the rebound hammer at the dome area. You can see all of these in situ strength. We got more than 40 Newton per millimeter square. So so that from the rebound hammer at the dome, we have consist by 10 point, which is I taking every 1 point will consist to 12 numbering of the rebound hammer testing. So this is our calculation from the wall. I take it from the wall of the rebound hammer. As we see, I have marking the numbers at the surface area to the reservoir. So this is our comments for the taking rebound hammer. Uh, After striking the concrete surface of the rebound hammer measure spring plugger, the inhibitor or to test accuracy, surface smoothness, surface size, concrete age, measure condition, cost aggregate types, and carbonation of the surface. So as we see the result RH1 at the dome area shown the calculation, we get a standard deviation. So 3.4 and coefficient of variance CV is 9.1%. So the main purpose of finding this value used to the rating for the degree control of the concrete plants have over product variable. If the CV is low, it is indicate a fairly uniform product. And conversely, if the value of the CV, which is coefficient of the variance, is high, the product will not be very uniform. For our testing at the RH1, we get the CV is quite low, about 9.1%. It is mean our testing can be accepted. So RH1, which is our rebound hammer one at the wall area, shown the calculation, we get the standard deviation for 1 and the coefficient the variance CV 2.1%. So the main purpose of finding this value used to directing degree control of the concrete plants have the over production variables. It is CV is low, it indicate a very uniform product, and conversely it is the value of the CV is high, the product will be not be very uniform. So our testing RH1 we get a CV is quite low, about 2.1%. It just mean our testing can be accept. Okay, this is our data collection from the ribbon hammer. So after second entity, which is UPV. So this is our range of the grade of concrete quality. So this is the guideline for pulse velocity above, then 4.5 above it is excellence for the concrete quality grading. 4.5 to 3.5 it is good. 4.5 to 3 it is fair. 3.5 is the poor. So this ultrasonic with UPV we get from the sample 10 point. So uh, from the every point we consist five four item for the distance between transmitter and receiver. Okay, as we see from the tables, the distance got from 100, 200, 300, and 400. So the transmit time, uh, we can conclude the data from we got the average and we got the pulse velocity. Then as we see the guideline before, so we can conclude the concrete quality. This UPV method use the method apply indirect. So this is our result for UPV. Okay, point one UPV1 got a fair. Point two until point five we got a poor. Point six we got a good condition. Point seven we got a poor. Point eight we got a fair. Point nine and 10 we got a poor condition. So this is our expect result. The last entity is cover meter. This is consist like this expected result for cover meter we're doing after this. Okay, this is our conclusions. Expected outcome of this research will be determine the technical condition of the reservoir water tank, provide guidelines on how to repair the strengthen of the structure using the NDT methods. So this is our guns chart for the research study. So 2021 until 2021 still under progress, and the last testing writing test is writing still under progress and continue until this January. So this our contents for this thesis presentation. Thank you for listening, and assalamualaikum warahmatullahi wabarakatuh.